Alright, hello boys and girls, this is Mr. Kizik, and in this video we're going to be talking about the right triangle congruency, the last thing we need to talk about, which is HL, and then doing proofs with all the different triangle congruencies. Now, just to let you know, the proofs are not difficult. It's everything that you have learned already, it's just now you're just doing it a little bit more formally. So, you may know why, sir. You may mark the pictures because that's what we did. We know shared lines we marked. We know vertical angles we marked. But what was the why? What was the property of something that told us we could do that? So that's just maybe something that will be new, but we've learned everything already. It's nothing new here. First things first, we're going to be talking about the last one, our little flipbook thing, HL. And what is HL? Stands for hypotenuse and leg. So it says if the hypotenuse and the leg of one right triangle is congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. So if I look here at the picture, I have S, S, A, and S, S, A. But you might be thinking, well, Mr. Kizik, you told us SSA is not a thing. You said that was a false shortcut. And it is. That still holds true. However, there is one possibility in SSA where I will only get one kind of triangle. And that's in this case here, when I have a right angle. So when I have a right angle, when I have a right triangle, I can get congruent triangles. It's enough information. So in this case here, if the hypotenuse, which remember is the side opposite of the right angle, so if BC is congruent to EF, and if the legs, in this case here, the leg is a side that's adjacent to the right angle. Now notice we really have two sides, and you might be asking yourself, does it matter which side it is? No. For all intents and purposes, this right figure, the markings didn't need to be there, they could have been right here, and these two triangles are still congruent by HL. But again, visually that doesn't look too pleasing. So they were nice enough to label it for you like that. So if that's congruent to that, and AB is congruent to DE, then the two triangles are congruent by HL. So triangle ABC is congruent to triangle DEF. That's it for HL. So HL is only a possibility if it has a right angle. But it's not necessarily true that if I have a right angle, I'm going to have HL. For example, let's say BC and EF weren't marked, but instead AC and DF were marked. This wouldn't be HL, this actually would be SAS. Right? So just because it has a right angle doesn't mean it's HL, it just means it's a possibility. So therefore, if my triangle doesn't have any right angles, I can't use HL. Don't even worry about it. Alright, so let's actually look at some proofs dealing with just HL here. So first one says triangle LMP and triangle MNP are right triangles, and line segment ML is congruent to line segment MN, and we want to prove that triangle LMP is congruent to triangle NMP. What you should do with any proof is just try to mark your figure or do whatever you need to do based on what they gave you. So the first part says the two triangles are right angles, or the two triangles are right triangles, so that means it must have right angles somewhere. Bam. They filled one in for you, I'm just going to fill in the other side. And then it says ML is congruent to MN. Okay, I'm going to mark it down. They told me so. Well, let's pretend this picture was like a question on a test. What else would you mark down? Well, you would say to yourself, well, I have the shared line, so I'd mark that down. That's what you could do. Take a step back and you would say, okay, I have a right angle, so I could have HL. Do I have the hypotenuse marked? Yes, I do. Do I have a leg marked? Yes, I do. Same for both triangles. So therefore, this is congruent by HL. Nothing new there. Now we're just going to write it formally. Statement. The two triangles are right triangles. Why? Well, they gave it to us. Given. Line segment ML is congruent to line segment MN. Why? They gave it to us. This next part here, MP is congruent to MP. Now, why do we do that? Well, our logical reasoning was, well, it's a shared line, therefore they gotta be congruent. But what's the actual property that says something is equal to itself when it's shared like that? You remember from Algebra 1, and we talked about it sometime with this chapter, it's the reflexive property. Reflexive property says something is congruent to itself. Think of the word reflection. You see yourself in the reflection. So maybe that will help you remember that. And then when we did this without the proof, we said we had enough information, and we said the two triangles were congruent by HL. And that's it. You are done. Okay, let's look at another one. Triangle WVX is congruent to triangle YZX, are right triangles. Okay, so they're right triangles, so we have right angles somewhere. I'm just going to put them right here, but we'll talk about in a minute why it really doesn't matter where they are. Then it also says line segment WV is congruent to line segment YZ. Okay, they told me. Bam. Bam. Then this next part here says X is the midpoint of line segment WY. Yes, you do need to remember vocabulary with geometry. That's why it was so important we did that in the first chapter, even though it wasn't the most exciting thing. Remember, what does midpoint mean again? It's in the middle. And what does it mean for a point to be in the middle? What do we know about the distance on both sides? They are the same. So you would be able to mark down that WX and XY are the same. And then the last part, prove that the two triangles are congruent. How? If I look here, right angle, I have the hypotenuse and the leg marked in each one. These are congruent by HL. Now again, you might be thinking, well, how do I know my right angle is there? Well, let's just pretend. Now, no one needs to say that the right angle is there. Yeah, sure, it could be over here. Don't I still technically have a hypotenuse and a leg here? I mean, I do. I mean, not visually there, but I do. So it doesn't matter where. It's just saying I have a right triangle. I got the possibilities. Notice how I didn't need to worry about this vertical angle here. I could mark it down. Yeah, I could. But then I have SSA, which remember is not a valid thing. Knowing that first part there, that's a right triangle, changes the whole problem here. So notice how it gave us 5 lines here to do our proof. Do we really need 5 lines? No, I could probably do this problem in 3 lines here. But sometimes, depending on what you're reading, the given portion, you notice how there's really 3 of them here, or 2 of them I should say. That's going to go for 2 of the problems here. All right. So, they probably want for 3 here. So the first one they said was triangle WVX was congruent to triangle, or it didn't even say congruent, I'm sorry. It said triangle WVX and triangle YZX are right triangles. And why? Because they gave it to us. And then they said WV is congruent to YZ. Why? Because they gave it to us. And then they said X is the midpoint of line segment WY. Why? Because they gave it to us. So our last statement here is going to be triangle WVX is congruent to triangle YZX, and we said because of HL. So we're missing this middle part here, and it is important. Usually when you do proofs here, actually not usually, always when you do proofs, when they give you something, especially something that has a definition or a vocabulary word in it, you have to define that vocabulary word and do the work to get to the problem. When we saw that X was the midpoint of line segment WY, that meant WX and XY were the same. So we did that. WX was congruent to XY. And why were we able to do that? Because that was the definition of midpoint. Because of what we knew there, it told me x was the midpoint of wy, I could have made that statement. Right? It's sort of like an argument that you're trying to have, trying to prove to someone this is why I was able to do it. Alright, so that takes care of HL there, and some examples that you might see. So now let's look at a couple of proofs where anything is possible depending on what's given to us. Okay, so number one here says L is the midpoint of Kn and line segment MP. What could I do there? Okay, so in fact, what I'm going to do here, just to color code it so we can see, I'm going to mark my figure black, anything that they literally gave to us. I didn't have to define any words. And then in red, I'm going to label things that I could label based on the words that were defined to me. So it says L is the midpoint of line segment Kn and MP. Remember, if something's a midpoint, the distance on either side is the same. So that means this KL is the same as LN, and ML is the same as LP. Now, if this was a picture on a test, what else would you mark down? You would mark down these angles are congruent. Because why? They are vertical angles. And then why would you say these two triangles are congruent? Hopefully you would say because they are congruent by SAS, right? We got an angle between our two congruent sides. So now let's write that formally here. So first part is the given. So for all intents and purposes here, we're mathematicians, kind of lazy. I'm not going to rewrite the given here. Just going to put a line given. So on a test, if this was an open-ended question and something like this here, yes, it's fine if you just put the little squiggly line in the given portion. Alright, so what did we do with the given? We marked down our congruent sides. We said KL, line segment KL was congruent to line segment LN. Why? Definition of midpoint. We also were able to say ML, line segment ML, was congruent to the line segment LP. Why? Also was the definition of midpoint. And then what else did we mark down in the figure? We marked down that angle MLK is congruent to angle NLP. And why? Well, because of vertical angles. You can put definition of vertical angles, you can put vertical angles, doesn't matter. And now we had enough information, so then we said triangle MKL was congruent to triangle PNL because of SAS. See how simple that was there? Nothing new that we learned here. You just need to remember some vocabulary words and some different properties. But through repetition, we'll be able to remember all these things. Let's look at another one. Number 2 says line segment BD bisects angle ABC. Okay, let's take care of that first given there. What does the word bisect mean again? Hopefully you remember it means cut in half. So that means this angle is congruent to that angle. And then it says angle BAD is congruent to angle BCD. So that gave us something. We didn't have to define any vocabulary, that it just told us. So I'm going to mark that. Angle BAD, BCD. Great. So now, based on the picture, is there anything else I can mark? It sure is. I can mark down this shared line right here. Then I take a step back, and since I am trying to prove the two triangles are congruent, they are congruent by AAS. So now let's officially write everything down here. So the first part, bam, given. I'm pretty sure for this problem that they have the given listed twice here. They have the first part and then the second part. Again, for me, it's fine if you do it in one line. And it's fine if you don't use all these lines here, as long as you have everything you need. Alright, so we don't need to define the second part, but we need to define that bisection. So we were able to put that angle ABD was congruent to angle CBD. And why? Definition of, now where do we divide? We divide an angle of angle bisector. If this was a line segment was bisecting, instead it would have been a segment bisector. Okay, next part, what else did we do here? We also marked down the shared line. So we would put line segment BD is congruent to itself. And why is that? Hope you remember from the other problem we did. It's the reflexive property. And we were done with everything else. So therefore, we looked at the triangle and we said, yeah, they're congruent by AAS. So triangle ABD is congruent to triangle CBD. Triangle CBD by AAS. And again, the reason why I have the extra line is because they would want the given listed twice. You don't need to do that. Alright, pause the video and try number 3 on your own. Okay, and then unpause the video to see if you were good in what you did. Alright, welcome back here. So, again, hopefully you looked at the given. You marked down anything that the given told you, whether it was a definition or a vocabulary you had to define yourself to mark it, or they told you different things. So the first part, S is the midpoint of line segment QU. Okay, midpoint means middle, both sides are the same. So I would mark down QS is congruent to SU. Then the next two parts, they told me. They said QR was congruent to ST. Be helpful if I mark the right thing. QR, ST. And then it said RS was congruent to TU. Take a step back. 3 sides congruent to 3 sides. That's SSS. Alright, so in your little proof here, again, you could have written the given 3 times. You would have said S is the midpoint of QU, line segment QU, Y, given. Next part, given, next part, given. I think that's too much work. So, line, write down all at once, given. What was the only thing we had to define ourselves from the given portion? The midpoint. We had to say or conclude that QS was congruent to SU because why? That's the definition of midpoint. We had everything we needed, so we said triangle QRS is congruent to triangle STU because of SSS. Right. That is it, ladies and gentlemen. I mean, could we have different variations of this? Yeah, I mean, it's very difficult for me to give you all possibilities of a proof here. So, if for homework here, I do want you to try these 3 problems here and see what you do. Again, if you don't use all the lines, that's fine, as long as you mention everything you needed here. So let's just look at these problems just quickly here. Forces given a right triangle, and then some other information here. I look at the picture, I see something else I need. And yeah, don't forget, since it is a right triangle, HL is a possibility. Not necessarily what it has to be, but it's a possibility. Number 5. Hopefully you remember what these symbols mean. If you don't, they mean parallel. So it says line segment KL is parallel to line segment NP, and then something else about those lines too. So you might have to think back to the last chapter when we did all the corresponding angles, alternate interior angles business in order to help you there. And then number 6 is kind of difficult in the sense of they overlap the triangles and it can be confusing. So if I look here, they want you to prove that triangle TVY here. So this portion right here, triangle TVY, is congruent to triangle XWY. So there is no middle triangle here. they just threw in an extra line to try to confuse you. All right. So that is it, ladies and gentlemen. And we are doing more proofs with this. We're going to do more proofs, you know, with this stuff here, but we're going to add something else to it, which hopefully is not too bad for you guys. Remember, if you have any questions or concerns, you can email me or, see me in the hallways, ask me a question then. This is Mr. Kizik signing off.